So I'm Ryan Carmaine. I am the student team lead for the Nameless Microwave. We are UAT's entry into the IGVC competition, which the IGVC tests engineers' abilities to design and build vehicles to autonomously navigate a course. I said click. That's the problem if the computer froze. Oh, there's the mouse. All right. So the IGVC is, all of these things here. We get to experience the electrical design, the mechanical design, software design with this. We are given a general competition layout, and we decide how we want to build our vehicle. We work with a group, obviously, and we get plenty of hands-on experience with working with it. These here are the sponsoring companies for the IGVC competition here. Each of these companies pays $5 grand for a seat at the competition, and this gives us plenty of job opportunities to talk to and apply for. So the competition site is held at Oakland University in Rochester. There we go. There'll be 4 different competitions out there, and we'll be competing in 3 of them. First one is the design competition, where basically we take this into a room, we sit down with judges, they look at the rover, we talk about how we designed it, and it's a presentation. The next competition out there is the autonomous competition that we'll be competing in. It's a 6-minute run time to do it, and we'll be judged on distance traveled and the smallest time to complete the course. This here is a drawing of the practice map that we will have. We'll start over here, and we'll run along our way here, hitting different waypoints. And at this point, we have one of 2 paths that we can go. We can either go up here, and then we come across this way to 3, or we continue down this path, hit 5, come over here and hit 4, and then come back to 1 again. From 1, we come back, we merge in here, we run around the flags through this path here, hit 7, and then come back to the finish again. The vehicle design needs to stay within the lines here while avoiding obstacles along the way. The last challenge out there that they have that we'll be competing in is the navigation challenge. We have a GPS that we will have on here, and they will give us a set of coordinates. We need to hit all of those coordinates and return back to the start again while avoiding obstacles. Here is the practice navigation field that they also provided in the rules. So you start in 1, 2, or 3, and you go out and you hit all of the other points along the way and come back to your starting point again. Awards while out there. Obviously, it's a competition. They offer awards. If we were to take all first place at the competition, we can win 16 grand. Since this is our first time competing, we also are participating in the Rookie of the Year award. In order to be qualified for Rookie of the Year, we must pass qualification in the design competition. We must pass the Rookie Barrel in the Autonomous Challenge. And we must make 3 waypoints in the Navigation Challenge. So, obviously, UAT gets publication and recognition here. All participating teams will get recognition through OVC and SAE publications. We're all invited to display the winning vehicles at the exhibit halls. And we are invited to go to the Unmanned Vehicle Systems, International Unmanned Systems, North America Symposium exhibition there. So how does this help UAT? We get exposure with the robotics field for the university. We get contacts with government contractors. We have the potential of winning 16 grand up to it. And we get contacts for career services, because I know robotics here is kind of one of those underwritten degrees, not too much contacts, that kind of stuff. Here are a list of some of the competitors from 2010. You can see like Embry-Riddle University here is another school in Arizona. You have the Missouri University of Science and Technology, which Ryan Muth is an alumnus of. And he also competed in this competition back in 2008. You got Rose Holman, many others along the way here. So UAT's entry into the competition here is what you see right over here. Our design is to use a stereo camera, LiDAR, GPS, an inertial measurement unit, or IMU, and webcams. All of this will be interfaced with a computer, which the computer will then interpret all of this information, send commands to the motor controller, and the motor controller will output that on the rover itself. We started off with these rovers here that are found up in the lab. These are parallax rovers, about $5,000. There was only about 16 made. From there, we went and we added the controller computer here on the right. The left over there is the propeller control board that is already on the rovers. We also are using these sensors here. This is the first slide of the sensors. This over here is a GPS unit that we'll be using. These are the LiDARs, and these are the stereo cameras. The LiDAR will send out a laser, take a horizontal cross-section of everything out in front of us. We can use that for obstacle avoidance. We also have stereo cameras. These will be used for 3D imaging around. So anything that the LiDAR sees, we can confirm that with the stereo camera. We also have webcams, and that over there is our inertial measurement unit. This gives us data like acceleration and rotation, that kind of fun stuff. The webcams here will be used for line detection to stay within the lines on the competition field. Our software design, it retrieves the sensor data. It'll go through an A-star path planning algorithm to avoid obstacles. It'll then send the commands to the motor controller. In here, it'll use a speed limiter and have direct control over the motors when it goes to output. So, any questions?
This is going to be outside?
Yes.
Right. What happens if it's raining?
It will run in a light rain or a drizzle, but it won't run in heavy rain.
So what happens if it's raining heavily?
They won't run the competition.
Okay. Oh, no, that's their rule.
Yeah.
Yes,
Like,
that's their rules.
But when we're done with setting up all the sensors and making sure everything's completely working, we are going to, our last level is to weatherproof everything just in case.
Okay. Cool. It's just sometimes if you're in Arizona, you don't think about
Yeah.
things.
Yeah.
That was my first one. I was like, water.
Yes, Jacob.
Sean, you said this came pre-built, like the base rovers, I guess.
Yes,
Modified?
this frame down here.
The hydraulic pumps and the skid part of the steering.
Cool.
Everything that you see from here down came pre-built. This metal frame up top is new for us for this competition.
Cool.
Yes.
You said that the lasers use a cross-sectional to determine the layout. What's the refresh rate on that, and would it be useful for actual moving obstacles?
Yeah, it spins pretty quickly. I believe it's got a resolution of 5600, which means that there's 5600 points, and then I believe it spins at
About 60 hertz, right?
yeah, about 60 frames per second.
It has a 270-degree viewing angle, so it can't see behind it, but it can see pretty much as far as it'll need to, because most of the time it's going to be driving forward and turning.
So how do you input goals into it? Do you just turn on and it runs, or like do you have to?
That's,
tell it to go?
yeah.
For the autonomous competition, we're not allowed to pre-map it or use any pre-built maps. So if you go to the software,
Oh, the software, I was going to go back to this one. What they're going to do at the competition is those waypoints that you see that are numbered, they're going to give those to us. So we can say, you know, we're starting way up here, and then we drive along to point 6. Then we can decide, do we want to come to point 2 and down to point 3, or come to 5, hit 4, and then go up to 1.
It's all just GPS locations that
Yeah.
they wait to release until you get there. And they're like, you can pick one of 2 paths. Here are the GPS points for both paths. Pick your poison.
Mm-hmm. They do the same thing for the navigation challenge as well.
You said you were going to be using webcams for little lines.
Yes. They're, I think they're white spray painted lines. Yeah, they could be dotted or dashed, so we'll have to work with either one.
There's also the possibility of there being ramps, which would be painted green like the grass, but they also are somewhat reflective, so they could appear white to the rover. So we have to take things like that into account, reflection, change the color of the sunlight, or
Yeah, so that's also why we have redundancy. Like you heard, we had 3 cameras on there. The LiDAR kind of acts as like the most basic visual we have at all. It's just, is something there or not? And then you have the webcams for the basic line detection, and then you have, on top of all that, you even have the stereo cam to like double check and triple check what we're seeing, just to make sure we don't mistake a ramp or something for something else.
Two questions, one related to the cameras. Did you guys look into getting a Kinect camera?
The stereoscopic camera is a Kinect camera essentially, or the Kinect is a stereoscopic
Yeah.
camera.
Okay. And then just curious, how much time was spent on engineering hardware and how much time was spent on software?
about 50-50.
Yeah.
Yeah, there was a lot of hardware work up front, but as we're getting a more complete design, it's turning more and more into software work.
When we first got the rovers, like there were leaks in the hydraulic pump system and stuff too, so we had to find that. We had to change speed belts and actually bring it up to even a base functionality so that we can then start putting the sensors and the motor controls and stuff we needed on there, because they had just sat in disuse in the lab for the longest time. No one had even bothered to maintain them.
For the low-level programming, working with the microcontroller, getting the feedback loops working, that was going back and forth with hardware and software, because we had to figure out what kind of sensors we wanted for the feedback loop, checking how fast each wheel's spinning, and then we had to tell hardware we want these sensors, and then we had to use different sensors, and we'd have to change how we actually read that. So it was back and forth with the microcontroller. Once we have that all dialed in, it's pretty much just sort of programming from there. Maybe adjusting the amount of spurt where certain sensors are moving around with it. But
Did you find yourself specializing team roles? As one guy's going to handle a specific piece of equipment, somebody else is going to handle a specific part of it?
Yes.
Kayla's hardware lead, I'm software lead. Last semester, right?
Yeah.
Last semester, this was still part of the class. It was
Robo War Games, Ryan Meath changed it into competitive robotics.
so we had probably about 10 people, and we split evenly between who had what skills. So we had one person working with the LiDAR sensor, one person working with the stereo vision. It's you, right, Lenny?
Yep.
And then we had somebody working with the inertial measurement unit, which is just accelerometers in 3 axes and gyroscopes. And then I was working with the microcontroller and interfacing everything with the rover.
And since we did have so many people, since it is a competition, we do have minimum and maximum specs we're allowed to have and we have to have. Like one of the things you see on the back, there's a red button. We have to have a emergency stop button on the bot itself and remotely. Sort of if something goes haywire because it's gas powered, it's gonna go until the gas runs out or something happens. So we're supposed to have that, so we broke it so 2 people were working on that, making sure that the circuit was good, finding what we needed to get as far as the solenoid we ended up using to pull the emergency stop, and the button itself.
The solenoid's down here, and all it does is flip the switch on the engine, cuts the engine power, so it can't run anymore because everything's powered by the hydraulic pumps.
What's that little one?
This is the track bot we're actually working on for the class right now that we're doing. Pretty much the bump bot program that we've been working with we're working with the exact same LiDAR we are for that. And it's pretty much sort of the same kind of steering we're going to be using. So anything we work on for this, for the LiDAR, just instantly ports over to that.
It's because that's gas powered, we can't run it inside. We have to have a test bed that we can run inside, and that's what this serves as.
Yeah, those were originally designed as basically pre-made platforms for robotic students to test their own designs with. So they're made to be modular. You can put any sensor you want on them. They run
Yeah.
next
Yeah.
week.
They're running Windows with Visual Studio, so you can program directly to run them. I think we have, we're using like remote desktop or something, right?
Yeah, you can turn it on and log into the desktop, program it, run it, do whatever you're gonna do, remote control it.
Yeah.
Yes, Chris?
Thanks. One, why did you call it nameless icon?
Actually, when we were thinking of names, I just searched the internet for name generators, and I came up with a punk band name generator, and that was the first result, and it somehow stuck.
Yeah, and we had for a while we had this, the dry race boards and the robotics stuff. We had a huge list going, and people would just put tallies next to what they wanted, and that ended up being the winner.
Mm-hmm.
So also, what is the future of this? Like, once you win or lose the competition, is this thing just going to sit in the robot lab until it breaks again and I fix it or something? Or are y'all going to keep doing something?
It's meant to be a competition platform for repeat coming back to here, but we haven't really talked too much about the future with this yet.
We'll probably figure that out after the competition.
So can we go check this out, like real close to Bowman's BMW?
If there's not any other questions, we can go for a demo.
Willing to take the responsibility for that one.
No, I
We
didn't
can
say
get
that.
the controller.
Yes.
So just gonna ask, like, I take it the majority of the testing has been on the little guy? For
Yes.
suspension in particular?
As
Yeah.
far as software and
Yeah.
the,
Mhm.
the path planning algorithms and spin.
But all the hardware and the motor control and skid steering and limiting the speed, because that thing could get up to 15 miles an hour, has all been out in the dirt lot, and then on the fly changing the software out there.
We've done some hardware tests around in the parking lot, that kind of stuff as well. Like,
Usually when it's not as bad.
yeah, like our most recent test was we had just put on the new frame, so we had to. We did some tests with how the gas tank was mounted, how the frame worked. As we initially had it mounted before we had all these angular cross pieces here, we just had a couple bolts in the corners, and you'd watch it when it go and take off. You see the top doing this.
And we had the gas tank on there with duct tape for a while, so we had to fix that.
Yeah.
It was 3 hours.
Yeah.
We had one sort of
Shall we?
Wild hybrid.
Should be mow our lawn.
Kind of wanted to see how far it would take the step. Like, wild hybrid.
That is so bad. Should be mow our lawn for us. That would be awesome. Predetermine the path to where it mows the whole lawn.
It's like a
We
Roomba.
don't have one of those. Why?
A Roomba of the lawnmower tool.
We don't have one of those because the next set guys would hack into the damn thing.
That's true.
What about not having something?
A robotic lawnmower.
That goes. It has the lawn predetermined.
People would be like, "Oh, you draw my portrait."
Shit, really again.
Oh, kill it.
Yeah, do it again.
Way to kill it then.
We did. We ordered the Lexam and the 3-bar, cut everything.
I think you killed it, Kayla.
The gas is really good.
Is there gas in those?
There was a little gas.
There's a little? Okay, might be okay.
Yeah, there's no gas.
He tells you.